Hello, Stat class. We're looking at 10 multis preparing for Chapter 7 test on Monday. So, if you are interested in preparing by going over those with me now, then let's do it. Here are the answers, so that will guide you to whether or not you want to go to all of the problems or just some of the ones. Alright, check yours against that, and now I'm going to go one by one. Alright, the first one is going to talk about a situation where we have 19% of all cars were white, and then they took a sample of 100 and it turns out 22% were white. So they wanted to know which were parameters and statistics, and that took us to the fact that parameters come from the whole population, so 19% must be the parameter and 22% comes from a statistic, and that's where, comes from a sample, and that's what a statistic is. So that leads us to the answer B. Alright, B as in boy. 19% is the parameter and 22% is the statistic. Alright, you can recall that. P, population, S, sample. Alright, the best statistics. Alright, on number 2, what we want when we're looking at statistics is we want the variability to be low, so that's the spread, and we want the accuracy. We want the variability to be low, and we want bias to be low. So does that exist in one of our answers? It does. D, as in dog. Alright, which of the following best describes a sampling distribution? So, I'm going one by one. It says the distribution of values of a statistic found in a large number of simulated samples of size n. The word simulated, it can be simulated, but that's not required. Simulated means drawn by the computer. So the distribution of all values of a statistic found in a large number of simulated samples of size n. Yeah, let's shy away from that. They do not have to be simulated. Part B, the set of all values of a variable in a sample of size n. Alright, the set of all values. Anytime I see the word variable in this chapter, we are graphing statistics, not variables. So it's not a random variable like last chapter. So let's shy away from B. C, the set of all values of a variable again. So let's go away from that. And D, the distribution of parameter values in all possible samples of size n. Well, we're not going to graph parameters in a sampling distribution. It's going to be from the sample, so it's going to be a statistic. So shy away from D. Let's hope we don't have to shy away from E. A probability distribution that describes the relative likelihood of all possible values of a statistic. Alright, so we're not used to calling it a probability distribution, but it could be thought of that because it is a distribution. The area under the curve does tell you the probability. So that was a little on the bratty side, but it is E. Alright, they couldn't just describe it the way we did plainly. Now they had to dance all around it, but that's stat, bratty old stat. In a large population of adults, the mean IQ is given, and the standard deviation is given, and they're selecting 200 adults, and the sampling distribution of the sample mean IQ is, well, it says that we started from a large population of adults. It does not say that they were normal. We're looking at the mean, so that's X bar land. So X bar team, you're up to bat here. So X bar, we can test for normal if it comes from a normal population, which this one did not mention, and it did say that the number n, when they drew the sample, there were 200. So n equals 200. So according to the central limit theorem, when n is large, which we defined as greater than or equal to 30, we can assume approximate normality. And the mean of the sampling distribution will be the same as the mean of the population, in this case 112, but we have to calculate the standard deviation provided n, 10 n is less than big N. So 10 times 200 is 2,000, which is way lower than the large population of adults. So it did pass that. So the standard deviation is going to be the old standard deviation, or the standard deviation of the population divided by the square root of n. So in that case, we get the old standard deviation is 20, and the population of adults is 200. So when I put that in the calculator, I got something like 1.4. So that leads us to selection C, which is approximately normal, mean 112, standard deviation 1.414. All right, moving right along. Number 5. All right, in this one, there's a study going on of the effects of acid rain. A random sample of 100 trees from a particular forest is examined, and 40% show damage. Which of the following is correct? A says the sampling distribution of the sample proportion of damaged trees is approximately normal. So we are looking at, since we're looking at 40%, the statistic of interest is p hat. So we're going to have to test and see if p hat is normal. And the test for normality with p hat, so p hat team, you're up to bat here. The p hat team, the test for normality is n times p, is it greater than or equal to 10? And n times 1 minus p, is it greater than or equal to 10? So n is 100, the proportion is 0.4, so that is 40. And so this one's 100 times 0.6, that's 60. They're both greater than or equal to 10. So we can say that it approximates the normal curve. So let's see what A said again. The sampling distribution of the sample proportion of damaged trees is approximately normal. I'd say that is true. We'll check the others and see if we disagree with them. B, if we took another random sample of trees, we would find 40% would show some sign of damage. We could be above or below. We know it's unbiased, so eventually as we take rare samples, we'll have just as many above or below, but it's not necessarily exactly 40% on each or any random sample. So B is a no-go. C, if a sample of 1,000 were examined, the variability of the sampling distribution, so we're talking about spread there, would be larger than in a sample of 100. I hope we made it clear that as the number n in the sample increases, variability actually decreases, not gets larger. So no go. D, the standard deviation of the sampling distribution of the sample proportion of damaged trees is, that is not the formula, it is p times 1 minus p divided by the number of trees in the sample under the radical, so not times. So I go with A. A it is. Alright, number 6. Here we're looking at which of the following statements are true when taking a standard random sample from a large population. Alright, going down them one at a time. The sampling distribution of x bar has this given standard deviation, the population's standard deviation divided by the square root of n, even if the population is not normally distributed. That's true. You don't have to check for normal to find the standard deviation. You do have to check that 10n is less than big N, but I'm assuming oh no, on this one, we're looking at X bar. I misspoke. X bar on Roman numeral 1, we have to determine if n is normal by normality. Has nothing to do with finding the standard deviation of X bar. So we can do that whether it's normal or not, as long as 10n is less than big N. So let us assume that's true. So I'm going to accept number 1. The sampling distribution of X bar is normal if the population has a normal distribution, and we discussed that. It is true. So you start normal, your sampling distribution is normal. When n is large, the sampling distribution of X bar is approximately normal, even if the population is not normally distributed, assuming that large means large, greater than or equal to 30. And sometimes the number is a lot smaller. So let's accept 1, 2, and 3. So that's selection D. Number 7. Here, suppose you're sampling from a distribution that is strongly skewed to the left. Which of the following statements about the sample distribution of the mean is true? So X bar team, you're up to bat. A says, as the sample size increases, so n is getting larger, the shape of the sampling distribution gets closer and closer to a normal distribution. That is true. All right, similar to one we had in number 5. I guess we were talking about proportions up there. So in this one we are talking about the mean. So we're looking at X bar. On part B, as the sample size increases, the shape of the sampling distribution gets closer and closer to the shape of the population distribution. That's not true. It will get closer to normal. On C, the sample size, as it increases, the mean of the sampling distribution gets closer to the population mean. So as the sampling size increases, we know variability decreases. So the mean of that sampling distribution gets closer to the population mean. I can say that the whole graph gets closer to the population mean, but the mean of the means is unbiased whether there's a lot of spread or not. So I'm going to say no for C. Regardless of the sample size, the shape of the sampling distribution is similar to the shape of the population distribution. That's not true. As we've seen, you could start with a very odd shape, and sometimes when the sample size is small, you do not get a shape that matches. Regardless of the sample size, the standard deviation of the sampling distribution is approximately equal to the standard deviation of the population. No, that's not true. So the A is the one, and if you want to discuss any of those further before the test, I will write down your questions. I will address them with pleasure. Number 8. Suppose we wish to estimate the percentage of students who smoke cigarettes at several colleges. So Wabash College has 900 and Purdue has 36,000. So what should the relative size of our samples be from each school if we want the two sampling distributions to have exactly the same standard deviation? So we're talking about variability, and we learned that the population size does not affect the variability. So we are going to look for the same sample size from each, and that would be selection D. We should take the same size sample from each school. Remember the example of the corn scoop? That is the principle tested in that question. All right, on D, we have a proportion So you can see it right there. So we have a standard deviation of p hat, and the equation we're familiar with. And they want to know what conditions must be true before we can use that. Well, the only one is the 10% rule, which says 10 times the sample size has to be less than the population or equal to. So it's not that, that's normality. We don't have to have normal to come up with a standard deviation, so it is 3 only, selection C. Lastly, we have a census of a labor force, and we found the time it takes for people to commute to work with the mean given as 20.5 minutes and the standard deviation of 15.4 minutes. So what's the probability that a random sample of 40 people, so we're looking at the mean travel time, so we are at 40 people, so that's greater than or equal to 30, so we are allowed to take on normal privileges here. So 40 people have a mean commute time that is greater than 25. So we're thinking of the probability that the standard deviation, the x bar, the sample mean, is greater than or equal to, no, it's not greater than or equal to on this one, it says greater than 25, which doesn't really affect the calculation whether it says equal to or not. So we can assume normality because of the sample size being greater than 30 or equal to 30. So we just have to standardize this. So we're going to take the number of interest, 25, and subtract the mean of the sample and divide by the standard deviation of the sample. So working on that, it is the same as the population mean, which is 20.5. And we can work on that if 10n is less than or equal to big N. So we're in a large metropolitan area, so 40 times n, 40 times 10, I'm sorry, 400 is less than the whole population of a metropolitan area. So we're going to do standard deviation of the whole population divided by the square root of n. So we have 40 is our n, and the standard deviation as 15.4. So that will be our z-score. And the way they did it, they looked for the probability that the z-score is greater than that. And that one matches. Let's see, what's wrong with this one? This one you have to have the number of interest first, so 25 should go there. Here it is, B. This is it. Alright, the others do not have the correct setup, so B is the correct setup. Alright, hopefully you found that those weren't too bratty and helpful, and more practice is always helpful, so helpful preparing your mind to do the multis on the test on Monday. Alright, very good. Carry on, class.